Welcome to Notes 11.3. All right, so way back in Unit 6, we learned that if we had similar figures, then their corresponding side lengths were proportional. And furthermore, we talked about scale factor, and we said the scale factor was just a ratio of their corresponding sides. So if I have two polygons that are similar and their corresponding sides are the ratio of A to B, okay, so let's call that our scale factor. Well, what we're going to find out in this unit is that if the ratio of their sides is A to B, then the ratio of their areas is going to be A squared to B squared. Okay, so let's look at that for a second. So I've got some similar rectangles here, and I need to find the ratio of the sides, the ratio of the perimeters, and the ratio of the areas. All right, well, the side ratios, I just compared the corresponding sides. So I can either take 5 and 15, which reduces to 1/3, or I can take 8 and 24, which also reduces to 1/3. So this would be my A to B. Okay, that would be my 1 to 3. Now, if I find their perimeters, well, the perimeter of this guy is going to be 2 times 5 plus 2 times 8. So his perimeter is going to be 10 plus 16, so 26. And the perimeter of this guy is going to be 2 times 15 plus 2 times 24. So the perimeter of this guy is going to be 30 plus 48, so 78 centimeters. All right, so my perimeter ratio is 26 to 78, which reduces to 1 to 3. So the ratio of the sides is the same as the ratio of the perimeters, still A to B. All right, let's talk area. So the area of this guy is going to be 5 times 8. So my area is 40 centimeters squared. The area of this guy is going to be 15 times 24. So my area is 360 centimeters squared. All right, so the area ratios would be 40 to 360. And this one's clearly not 1 to 3. This one is instead 1 to 9. And how do I go from this to this? I squared, right? So 1/3 squared equals 1 over 9, which means that this is the case for my areas. And this holds true for every similar polygon. If the side ratio is A to B, the perimeter ratio is A to B, and the area ratio is A squared to B squared. So looking at this pair of triangles here, first I need to do the ratio of the corresponding sides. Well, if this is my right angle, then these two sides are my corresponding sides. So my ratio, my scale factor, my similarity ratio is going to be 3 to 4, which means that my ratio of my perimeters is also going to be 3 to 4, and then my ratio of my areas is going to be 3 to 4 squared, which means the ratio of my areas is going to be 9 to 16. Questions? All right, so let's talk about when we are given areas, how we find the similarity ratio. So I've got two squares and they have areas 81 and 25. So the ratio of my areas is 81 to 25. And now I need to work backwards to find the ratio of my perimeters. Well, if this is A squared to B squared, then my perimeter ratio is going to be A to B. So to go from A squared to B squared to A to B, we just take the square root of both sides. So, or both parts of my fraction. So we are going to get 9 over 5. So this would be my similarity ratio. If I move on to my next one, and we have an area ratio of 10 to 360. Now these are not perfect squares. However, I can reduce this, and if I reduce it, I get 1 over 36, and these are perfect squares, which means that for my perimeter ratio, it's easier to take the square root. Square root of 1 is 1, the square root of 36 is 6. So this would be my scale factor. That would be my similarity ratio. All right, and for my two circles, my area ratio is 128 pi and 18 pi. Well, my pi's cancel, so I don't have to worry about them. These are not perfect squares. However, if I reduce this, they're both divisible by 2, then I get 64 over 9, and those are perfect squares. So then it's easy to take the square root of them to find the ratio of my perimeters, or my similarity ratio, which would be 8 to 3. Questions? Be sure you ask in class if you have any. For some reason, this is a difficult concept for many students, but it's very straightforward. And here's why it's handy. Okay, so I'm given a pair of similar figures, and I know the area of one of them, and I know the sides of two of them. Now, what I could do is I could work backwards from the area to find the side length, and then I could make a ratio of these two side lengths, figure out what this side length was compared to these two side lengths, and then I could multiply to find the area. But if I can just remember the relationship between scale factor, or the similarity ratio, and my areas, then I can do it in one step. So if this is the ratio of my sides, 7 to 15, and I want to compare it to the ratio of my areas, well, the area of the one with a side of 7 is 84, and the one I'm looking for is the area of the larger figure. Okay. These are not equal. They're not equal until I take that similarity ratio and I square it. Okay? Think about it like this. These guys are in centimeters, and this is in centimeters squared. I can't compare centimeters squared to centimeters until they are the same. So I need to square the centimeters to make them centimeters squared, which means I need to square what they're with. All right, so then what I get is 49 over 225 equals 84 over x, and then I cross multiply and I solve. Go ahead and do that and tell me what you get for an answer. Come back once you've got it. Hit pause now. Okay, you should have gotten 385.7 centimeters squared. So you can see that doing it like this was much easier than trying to find the ratio of these two sides and then going ahead and multiplying it. Takes fewer steps. All right, I would like you guys to do this one in a similar fashion. So go ahead and set it up and solve it and come back when you have your answer. Hit pause now. Okay, so you should have set up the similarity ratio and then squared it to set it equal to the ratio of the areas. And then when you cross multiply and solve, you should have gotten 46.1 inches squared. All right, so now down here we have a pair of similar figures, and we need to find the ratio of the perimeters. Well, if the ratio of the areas is 50 to 8, this reduces to 25 to 4, then the ratio of my perimeters is going to be the square root of these, which would give me 5 to 2. And then that's my answer, right? We're just going backwards again. We've got the squared ratios, and we need them to be square rooted. All right, you guys do this one and give me the answer in the notes check. All right, word problems. Love word problems. Okay, so we've got some rectangular pieces of window screening, and one is 15 feet long and costs 135. The other is similar in shape and 20 feet long, and it's sold by the square foot. What is the cost of the longer roll? All right, so first we got to figure out what kind of problem are we dealing with. And if it's sold by the square foot, so price per square foot, then we are dealing with an area problem. And we know that if we want to compare prices, and the prices are measured in terms of area, then we're going to need to take our similarity ratio, which will be 15 to 20, And in order to compare and find the price of the bigger one, we are going to need to do what to our ratio of our sides? We're going to need to square them because this is my scale factor and I need to square it to solve. So if you would please go ahead and tell me how much the screen in a longer roll is. And come back when you have your answer. Hit pause now. And you should have gotten $240. All right, next problem. A stop sign mat is a regular octagon. Each side is 2 feet and the area is about 19.3 feet. You make another mat with a perimeter of 72 inches. We need to find the area of the new mat to the nearest tenth of a square inch. Okay, so let's talk about what's going on here. We have an octagon. It's got a side of 2 and an area of 19.3 feet. And then we've got a mat with a perimeter of 72. Well, how many sides does an octagon have? 8, which means that each side is going to be 72 divided by 8, 9 inches. And we need to find the area of the new mat to the nearest tenth of a square inch. Okay, so this gets a little complicated because some of the measurements are in feet, some of the measurements are in inches. And let's talk about how we can do this. A lot of you are going to want to convert. You're either going to want to convert the feet to inches or the inches to feet. Now, keep in mind, our final answer is in square inches. So if you want to convert, you're probably going to want to convert feet to inches. But a lot of you, when you convert this 19.3 feet squared to inches, you're going to do it wrong. I have a proposal for you. You don't have to convert. And here's why. Okay, so let's set this up. So we have my side ratios. One of them is in feet, 2 feet. One of them is in inches. And then we're looking for the areas of our mats. So one of them is in feet, and we are going to want one of them in inches. We know that if this is the ratio of the side length, then we have to square it before we can use it. And when we square it, we find out we do in fact get square feet to square inches. And believe it or not, this proportion works. The units do not have to be the same for the proportion to work. So what happens is, let me see, I get 4 feet squared equals 81 inches squared, not equals, but is proportional to. And then I have my other side of the proportion, which is 19.3 feet squared, and we want to know how many square inches the other mat will be. We can simply cross multiply this and solve, and when we solve it, our answer is going to be in square inches. And I believe when we cross multiply and solve, type it into our calculator, we get x equals, and we get 390.8 inches squared. So takeaway is, if this proportion is true, if this ratio is true, and the units match, you don't have to convert your units in order to be able to solve. All right, moving on to the next question. So we are given that triangle ABC is similar to triangle DEF, and we need to find the ratio, shaded to unshaded, of the perimeters and the areas. You know what? This is very straightforward. I'm going to ask you the answer to this question in the notes check. And that actually concludes our notes for today. Pretty short. So be sure that you go on and do the notes check. And if you have any questions, be sure that you ask in class. Thanks.